It says it's recording. Oh, finally, now I got the red button. All right, class, FYI, so the computer had started recording, and I think this is a very important recording that I think you will find an advantage of doing this, particularly for this particular tutorial lesson. So if any part of the step in creating the project number 2, which is all about the demonstration of the law of conservation of mass, you can simply go back to the recording in the Google Classroom and play it in the comfort of your home. You can watch the video. All right, I hope this benefits you. All right, now, before the recording, we took the time to have a pre-discussion, okay, before the demonstration of what we would like to accomplish. As we have said a while ago, and I know most of you, which you, if you haven't typed the word either demonstrate or show, you can do it now. It will be not similar to what we've done in the past, because this one we are going to use a different chemical equation wherein our goal, the main reason why you eventually will gonna show what you have learned is for you to demonstrate or show if a chemical equation follows or demonstrate or show the law of conservation of mass. In the lessons we had in the past, we've learned that an equation follows the law, follows the rule, if the elements on both sides of the equation, the reactants and the product, are of the same kind. In this case, we are going to use, remember, before the recording, we identified the 3 elements, and they are the carbon, hydrogen, and oxygen. If you did not put it in the room before the recording, it's not too late to put these symbols. C is for carbon, H for hydrogen, and O is for oxygen. To make life easier, we don't need to write the whole word, just simply use the symbol. All right, and for modeling purposes, in other words, to represent these elements, I am going to use 3 different kinds of beans, and we have seen that before the recording. All right, once again, we said that these beans that I have, which I will have them available for you in the office, you can just use your own beans, by the way, as long as they are of 3 different kinds, because we're using 3 different elements in this chemical equation. All right, once again, let's take a look at the beans and what each of them represent. What particular element does each bean represent? Okay, so here they are once again. So we will need to use a lentil. Okay, tiny. Oops, did you see that? It jumped. The jumping bean. The lentil is for oxygen, and this is represented by letter O, capital letter O. Garbanzo bean. This is the garbanzo bean. I love garbanzo bean. And the black bean represents the hydrogen. So I want you to keep this in mind as we move on to the demonstration today. So you know what each bean represents. All right, tell me first, are we crystal clear at this point in time? We're just beginning. Tell me, are we crystal clear with our goal? Tell me. Okay, I can see names. Christopher, you were the last one who said yes, excellent. If you haven't put your name, it's okay to say no, so I can repeat, right? But if you said yes, make certain that what we want to accomplish is clear. Again, we want to make certain that the equation that I am going to show you, which eventually you are going to DIY, do it yourself, okay, DIY. That's the time when you actually show that you understand. Remember, listening may make us not remember, but by listening and looking, watch me, then you will remember. But doing it on your own, then you will find, oh, I got it, I understand. All right, so we want to know if the equation demonstrates the law of conservation of mass is right in front of me. All right. So if you haven't typed anything in the room telling me that you it's crystal clear, it's do so now. Thank you, Jesse. You're the last one who said yes. Appreciate that. Keep being with me. Let me check. Excellent. It looks like yeah on. And right, class. We're just beginning. So there are several pieces in this project. Please pay close attention. All right, now let me refocus the camera and you will see I do have some of the things that I needed to use. And this, I will not use this yet. I will leave this here. Okay, and in this small cups, I do have all the beans that I need. Okay. And I need you to find out and tell me how many beans do I have in each cup. Let's do a bit of counting here. Remember, in an equation, we count how many elements are present. Okay, so here, first, since we are using beans, we're going to count how many beans or seeds, I would say, are present in each cup. We should not have more or less exact number. First, we have the black bean. Let's start with the lentil. Lentil, carbon, and the black bean. All right. Now, in this jar, I do have the lentil that represent the oxygen. Could you tell me how many lentil do we have? Count, please. How many lentils do we have? 6. Excellent. These 6 lentils represent oxygen. Lovely. What about the garbanzo, which represent the carbon? How many garbanzo do we have? Type in the chat. Thank you. Lovely. 2. Oh, I feel good because it looks like I'm not the only one here. All right. Last but not the least, the black beans. This represent the hydrogen, capital letter H. Oh, tell me how many do I have here? Ah, sorry, the one is black bean is not cooperating. Oh, it's falling. It's circle. Anyway, so go ahead. Please tell me how many black beans I have. 8, right, Christopher. 2, 4, 6. Oh, that was a okay. Really, close count there, huh? 8. Excellent. If you haven't counted yet, where these are quantitative data. Quantitative. Remember the quantitative and qualitative. Black is the color, quality. All right. And quantity. Now we're looking at the quantity. Excellent. So these are the numbers of beans that will represent each of these elements in our project. Sorry, it should be the other way around. Oh, upside down. All right. So keep in mind, the elements are represented by the beans. Beans as elements. And here is my list. When you create a project similar to this, you got to have a list as well. For you to follow it correctly. Because we're doing models or representation. So I will put all the beans back in the respective cup. And then eventually I will take them one by one as I assemble the equation. So they go back to the cups. These are my 6 lentils, my 2 garbanzo, and my 8 black beans. See, it fell again. Where is, there you go. How many times did the black bean fall? Tell me, how many times did this black bean fall? Does not want to be caged. All right, I think 3 times. So this, I will set them aside. I will use them a bit later. So I save it. Excellent. All right, let's back up here. How are we doing so far? We're just, we're almost halfway through. How are we doing? Is things clear for now? Hopefully till the end. Tell me if is it clear? Better? Okay. You're getting some, okay, maybe a little bit concrete ideas on what are the beans for. We're creating, I'm going to create a model. We're doing modeling here of a chemical equation that will demonstrate the law of the conservation of mass. Okay, let me start once again. Please be with me. This is the other essential part of the lesson tutorial on how to set up your project. I need colored papers. They will be available in the office. I will put them, bring them in tomorrow morning. So afternoon, yet tomorrow, it will gonna be available for you. Again, if you are in a hurry, you can use your own supplies. You can even select a different kind of bean seeds. Does not need to be lentil, black bean, or what's the other one? Garbanzo. As long as you have 3 different kinds of frijoles, 3 different, because these represent the 3 different kinds of elements. Okay, let me refocus the camera. Okay, so what I need to continue the process, I will have to have a paper with the equation I want to assemble. Of course, an equation has an arrow. That's the arrow. Everybody, please take a look. I am in the process of putting the equation together. Now, we have learned that these elements and compounds, let me get a pointer. Excellent. I'm back. We have learned that this element and these 2 elements combine as compounds if they are before the arrow. Again, they are the reactants. When they become together, they will produce a product at the end of the arrow. But class, look at this. There are 2 products that we are going to assemble. This one could be a bit complex. So pay close attention. It's not as simple as before, isn't it? When you're learning how to, a certain sport, your coach will give you, easy to do first. And then as you move on, as you become a little bit of pro, from amateur to pro, then it becomes more kind of complicated. And that's how learning is. So this time we're adding another product. It's not just 1, but 2. All right. Are you still with me? Type in the chat. Type in the chat. Are you still with me? Excellent. Please follow along because, as I said, this is a bit complex. Because this is not the first time that we're learning this. I want you to put a bit of complexity in your work. All right, let me refocus. All right, so now we do have the products, and there are 2. CO2, and we have 2 water molecule, which I'm using the word 2 water molecule. You will see how I will show this using the beans or the seeds later in time. All right. I do have the equation. Now, it's time for me to use the beans. Now, initially, we know I will refocus the entire image so you will be able to follow along with me. Lovely. Can you see well? Can you see? Tell me now. Can you see well? Everybody, please. You got to tell me. Excellent. Lovely. You should be able to see the entire yellow. Okay. Now, keep this in mind. This is our representation. Class, I will need your help in determining how many elements of each kind in every step of the way. So be ready to count, look at the number, and put it in the comment box. I need your help. And at the same time, you are telling me, showing me that you are with me as we move on in every step of the way. Because this process is multi-steps or multi-steps, several procedures, why you can watch this recording later. But I need you to be with me now. So if you do have a question, you can ask me. There's a raise hand button. You can activate that or simply put in the comment box and I'll be monitoring any question. All right, let me refocus once again. So we have these beans in the cup. All right, now they're back into action. Gonna leave it here for the time being. Make certain that they won't fall. All right. Now, oops, it's covering. Let's put it here instead. Okay, now class, everybody please. I'll do it one by one. I need your help. So here you have C, H, and 4. I have 4H here, 4 hydrogen. How many C do you think I need to have here? You have 1 minute, Guadalupe. And let me know when you return, huh? You have 1 minute. Could you tell me how many carbon do I have? Yes, correct, Christopher. Good analysis. Yes. Please put that in the chat. 1 only. Here I have 4. And my carbon or C is using garbanzo. All represented. The representation is garbanzo. I get 1 garbanzo here. So this is my first garbanzo. That's my C. Hydrogen, I need 4. 4 hydrogen, it says H4. So my hydrogen is my black bean. And I need 4 black beans for my hydrogen. Lovely. Since they are together, I will just put the black beans around garbanzo. Lovely. Kind of like it's a merry-go-round here. All right, there you go. Bob is your uncle. All right. So far, I've assembled or put the seeds together to represent CH4. I got 4 black beans, 4 hydrogen, 1 garbanzo, 1 carbon. All right. How are we doing so far? Tell me your kiss of 5 at this point in time. 5, I know it's a well teacher this time. We can move on. 4, I'm good. 3, I need question. 2, I'm a bit confused. I gotta catch up. And 1, I'm beginning. It's okay. Especially if you got disconnected. It looks like no one has gotten disconnected, and I can see you are with me. Thank you. Appreciate that. Wow, 4. Great. Okay, if you need a bit of assistance, okay, please be with me all the time, huh? All right, you know who you are. So it's okay. I'm glad you're honest. Excellent. Now, let's do the next step. The next step will be quite similar to the first step in putting it together. It's still counting, but a different element. So here you will see it again, but using a different element still in the reactant. Okay. Moving on. So now I have, since I need another element here, I will need to put a plus sign here. Oops, doesn't work. Let me get, oh, I got my Sharpie. Love it. I'm going to put a plus here, meaning to say I will need to combine the two, plus. Now tell me, how many oxygen do I have, do I need to have? How many oxygen? I need help. How many oxygen do I need? Put it in the chat room. How many oxygen do I need? Waiting. How many oxygen? Here I need 4 hydrogen, but here how many oxygen do I need? What's this number? 2, correct. Vincent is not, 6 is total. You're right, Vincent, when you add them together, but this time I just want to know how many oxygen. And Jesse said 2. All right, you're both correct, but Vincent, you are correct if we add, but I want this one only correct. The correct answer is 2. Everybody please put number 2 in the room. So far, Jesse and Vincent have responded. I'm waiting. Brianna, thanks, Brianna. Okay. So now we need to have 2 oxygen. And oxygen is represented using the lentil, the teeny small kind of reddish, light reddish seed. I love lentil for my soup. And this is the lentil, and I need 2 of it. 2. Excellent. All right, now we have the 2 reactants, and they can combine. So in our lesson in the past, a chemical reaction, which is an equation, is made up of 2 parts, the reactants and the product, and in between is the arrow. After the arrow are the products. I said are because here we have 2 products. Now, very important part of the lesson, looking at how will I assemble this product. Now, here I need your assistance once again. I will assemble this CO2. Could you tell me how many C do I need? And this C is represented by garbanzo. How many carbon do I need to have here? Excellent, Christopher. Good. 1. Okay, everybody, please show me that you are with me by putting your name in the chat room. Lovely. Excellent. Thanks, Carlos. What about the rest? 1. Yes. And 1 carbon, there's nothing left. Remember, I counted it first. I got 1 carbon here. Then, how many oxygen do I need to have? How many oxygen? Right. Good job, Christopher. 2. So my oxygen is my lentil. So I got 2 lentils here. Since it is a compound, I was just gonna put 1 next to each other. That is my 2 oxygen and 1 carbon. Lovely. Remember, huh? It's quite complex because there is another product after the arrow. There's 2. So here, there are 2 water molecules. Class, pay close attention to the last step in putting these seeds together, because the H2O, I will need to have 2 of it. I'm going to call it 2 molecules of water. So you will see me creating 2 sets of water molecule, because according to the equation, there are 2. All right. Are you still with me? Type in the chat. Yes. All right. Pay close attention, huh? This is a bit different. As I told you, it's quite a bit complex. So I'm going to make 1 water molecule first. and I will just simply duplicate it to make it 2. Kind of like making a copy. Kind of like making a copying and pasting. Copy and paste. They are identical. All right. Look at this one. Moving on. So, I need 2 hydrogen, and my hydrogen is a black bean. 2 hydrogen. This is, and then could you tell me how many oxygen do I need to have? How many oxygen do I need? 1 or 2? Yes, Christopher, correct. 1. And my oxygen is lentil. I got 2 left. That's my oxygen. So I have 2 hydrogen and 1 oxygen. My hydrogen is the black bean and my oxygen is a lentil. See how I use my codes? I go back to it to make certain that my seeds are representing the correct element. So when you do it yourself, you gotta list them down. You can, as I said a while ago, you can use, as I said a while ago, okay, someone, hold on. Maybe, let's admit, hold on. Someone is trying to get into our system, which I don't even recognize who that person is. That's why I denied the person. So I know who are supposed to be in our Google Classroom. So somebody, sometimes it does happen. I just simply click deny. You're not part of the class. Right? So we want to be safe. Let's move on. All right. Where did I stop? Oh, yeah. So now I have 1 molecule of water. Remember I said I'm going to make another one. I will just simply duplicate it. So since I need to have 2 water, I need to have my other water right above. So I need 2 oxygen and my hydrogen, and it's the black bean. And there you go, the lentil, it's gone. Oops. So right here. So now, have I used all the beans? Have I used all the seeds? Have I used all the seeds? Yes. I have used all the seeds. That is say, they are exactly counted depending on how many elements do I need. Nothing is left. So when you assemble, make sure you count the seeds first, or whatever object you are going to use to represent the elements. Because in the law of conservation of mass, we are particularly interested on what kind of element are we using, carbon, hydrogen, and oxygen, and how many, for us to know if they follow the law of the conservation of mass. Okay, so far, how are we doing? We are almost on the final step. How are we doing so far? Okay, so 5 again. I know it very well. I can teach anybody. 4, I can do it by myself. 3, I have a question. 2, I'm a bit confused. 1, I'm still beginning. Show me your fist of 5. I'm waiting. I'm looking for your name here, right here. Oh, good, 4. If you haven't shown me your level of understanding, thank you, Christopher. The rest who showed me, excellent. Looks like, oh, wow. All right. Mostly are full. All right. Excellent. If you need a little bit of help, okay, keep on watching me. And you can watch this recorded video again. Or first time, I would say, because I still have to post this one and finish the lesson. All right. Last few steps. Remember, our goal is to find out if this follows the law or demonstrate the law of conservation of mass. Oh, sorry. Not the, okay, and we use these elements. The law, where's my, yes, right here. The law of conservation of mass. Now, let's do the counting. If we'll find out if they are balanced. Remember this in our lesson in the past. The number of elements here are similar to the number of elements there. And this was part of our lesson in the past related to this. Let's apply. Okay? Now, let me refocus the camera once again. This time, you are going to tell me how many quantitative data. All right, everyone, please, okay, take a look. And your response will be numbers or count in the room. Now, first, let's look up, because you want to know if this demonstrate or show the law of conservation of mass. How many, let's take a look first. Look at the black beans here. How many black beans do we have in the reactant? Type in the chat. And these black beans represent the hydrogen. Sorry, how many black beans do we have here? How many hydrogen do we have? 4, right? There are 4 hydrogen in the reactant. What about in the product? How many black beans do we have? Or how many hydrogens do we have? 4, correct. Lovely, that is say this hydrogen and this hydrogen, they are equal. I'm gonna give it a thumbs up. In other words, by just simply looking at just one, and there's 2 more, we found out that the hydrogen here and the hydrogen here, reactants in the product, are equal in number. So far, the hydrogen follows the law. They are equal or balanced. All right, let's move on to the next 2 elements. Let's look at carbon, which is the garbanzo. See, I'm looking because there are codes here. So the carbon, how many carbon do we have here? How many garbanzo do we have here in the reactant? How many? 1, right? Correct. If you haven't put the number 1, please do so. Now, what about on the product side? You will see I'm jumping from one side to the other side. How many do I have here? How many? Yes, 1. So that is say the number of carbon on both sides of the equation is equal. I would say, well, hydrogen, it's okay. It follows the law. The numbers are the same. Carbon, it's also okay. It follows the law. All right? Excellent. What about the oxygen? Could you tell me? No. Tell me. Do we have the same number of oxygen lentils on both sides? Let me give you a quick moment to take a look once again and tell me yes or no. Yes, if they are of the same number. No, if the count is different. Could you tell me yes or no? Look at the lentil. Okay. Oh, hold on. CO2. Now, are we now on the lentil oxygen? Look at the lentil. Do we have? Yes? Do we have the same number? If I take this one away, do we have the same number? 1, 2. 1, 2. Do you have the same number? No. That is say, oh, it's not the same number. So if it is not the same number, even though we have this H2O, so we have oxygen is lentil, therefore, it looks like this does not follow the law. So this oxygen does not follow the law. Okay? Because this we have 2, and this one how many? 1, 2, 3, 4. Yeah. So that is say the rest of the elements, they follow the law, but not the oxygen. Right. How come they're not following the law? Are they equal in number or unequal? Tell me. Are they equal or not equal? Unequal. If they are unequal, they're not following the law of the conservation of mass. But if they are equal in number, then just like the carbon and just like the the carbon and the hydrogen. All right. Are we clear so far? Are we clear? Give me a thumbs up. Alrighty. Okay, now, so last few steps that I need to do is to put them semi-permanent by putting a glue. All right, that's the final step. You should have a glue because that is one of the requirements that we had in the past. So I will show you how will I put them together. Everybody, please take a look. So first, I will definitely the glue. I want to put all the pieces together, and this is my chemical equation. So first the arrow, put a small amount of glue. Hold on, it's dry. I need to clear that. There you go. Glue here, arrow, and my reactant. Glue, and my product. Glue. All right, now, of course, I will need to put a bit amount of glue for each seed to keep them in place. So this is for my garbanzo. That's for garbanzo. And I will simply put 4 dots around. 1, 2, 3, 4. And I will use the pen to kind of push this. Pick it up and pen this one as well, and that one as with a more glue here. Lovely. Next is my lentil, my oxygen. 2 dot 1, 2. 1, 2. All right. Easy to glue, isn't it? All right, so that's the first part of gluing. That's for the reactant. Now let's go to the product. For the product, I got my carbon, CO2. This is the lentil. I'm sorry, not the lentil, the garbanzo and the lentil. Oops, has quite a lot of glue. We use this one. Oops. You can use a stick if you don't want to mess up your pen. All right. Next, the 2 waters. The 2 waters. 2 and 3. 1. 3. And then the other water here. 1, 2, 3. My chemical, oops, sorry. And then glue this one as well. Okay. Oh, is your uncle. Meaning, that's the way to do it. The final step is to put them together in a glue. Now, I do have an equation that most of the elements follow the law of the conservation of mass because they are equal in number. All right. Now, in order to make certain that I remember the representations of the each of the being, I will make certain that I have this next to the project. I will also glue this one next to the project. And this is my chemical equation. All right. So how are we doing so far? Tell me a piece of 5. I know it so well. Teacher, I know the procedure. I can do it and I will get my materials ready. All right. 3, 4. I can do it by myself. 5 is you can teach. 3. I have a question. 2. Confused. And 1. I'm beginning. Tell me your level of understanding. Okay. Looks like all good. If you haven't put your level of understanding, please do so now. All right, now, so of course, this will need a bit of a time to, oh, good. 5 Guadalupe, you can, Guadalupe can teach anybody. So it takes a while for the glue to dry up. All right, now this, when they dry up, whenever you're done, which I do expect by the end of the week, this week, when I do the inspection, you're able to show it to me. And this goes part of your science wall project. All right. So I will put all the materials except the glue in the office and you can start picking them up beginning tomorrow, okay, after school or during lunch. All right. Or you can use your own materials if you wish. All right. So I'm going to turn off the recording now. Stop recording.